our topic uh, for today's session is Internet of Things and its applications in energy management. So, first we need to just look upon what is IoT, Internet of Things, and because it is related to connectivity of things, whether we are connecting those things virtually or physically, and the wireless connections obviously is taking place. So this ITU came into picture, and ITU is International Telecommunication Union. So the ITU-T, which is Telecommunication Standardization Sector, has defined IoT as a global infrastructure, and that infrastructure which basically we want to interconnect either physically or virtually, and those infrastructures will be connected based on our existing and also evolving interoperable ICT technologies, which includes basically the wireless communication technologies and other standards and protocols which are going to be incorporated in these type of applications related to IoT. And also this all interconnections are basically done because of the information we can transfer between the devices, between a person and a device, from one machine to another machine, and so on. So this is the one definition provided by ITU, and because some of the standardizations of these technologies and some protocols and you can say devices are going to be utilized with the IEEE, which are IEEE standardized. So that is why IEEE also has some definition, and they produced a special report on 2014, where they have identified that it is considered as a network of items, and this network of items are embedded with sensors and which are ultimately connected to the internet. So in brief, we can say that any network of physical objects, which are devices, vehicles, buildings, or any other items, and those items are embedded with your electronics, their software, sensors, and network connectivity, and they will enable those objects to collect and exchange the data. That is to be considered as Internet of Things. The concept of this connected devices, because Internet of Thing is basically connection between the devices. So the concept of this connected devices came into picture in 80s, because in 1982, as per the history, this three students from CM University, they basically tinkered with their soda machine, and they made a history which is came into picture as a concept of connected devices. Because what they basically want to do, they just want to know the inventory level of their nearby Coca-Cola machine. So they installed some micro switches, and those micro switches, they are relayed the inventory levels on the machine rack and reported whether the newly loaded drinks were cold or not. So it means they just want a solution for a problem they are facing, and for that solution they have installed some micro switches, and those micro switches are basically relaying the inventory levels of that particular Coca-Cola machine. And finally they report that inventory levels with some new additions they want, that whether the newly loaded drink were cold or not. So they gathered that information and they reported that information, and with this the connected devices concept came into picture. Then again in 1990, John Romke and Simon Hacknett, they accepted a challenge to connect and control a toaster via the internet. They have tried that, and again the connected devices concept came into picture. But exactly in 1992, we can say the Kevin Ashton, which is co-founder and executive director of MIT, he coined the term IoT, Internet of Things. So he has given the concept of this, that connected devices is basically considered as the Internet of Things, and he has made a presentation in a conference, and where he would talked about linking your RFID tag in supply chain to the internet. So the first commercial application, you can say, which was proposed was the linking of RFID tags for to the internet, and that too for the supply chain system. And then the widespread use of the term Internet of Things came into picture in 2000, and the first international conference of this concept was held in 2008, where the topic of discussion was RFID, short range wireless communications, and sensor networks. So on basis of that, in year 2000, LG also launched refrigerator, which is considered as the internet digital diodes in itself in the 2000. And the another landmark which came into picture regarding IoT is 2008 and 9, in the year 2008 and 9, because in that landmark you can see And you can observe from reports also that the things connected on the internet is much greater than the humans connected to the internet at that time. So during the implication and you can say the starting of IoT in 2011, IPv4 till 2011, IPv4 was considered to be the addressing process, but then it is shifted to IPv6. And in 2014 itself, the CEO Cisco System, John Chamber, said that IoT will be a bigger thing, anything that's ever done in high tech, and it will change the way people live, work, and play. And you can imagine nowadays how our day-to-day life is impacted with the use of this internet of thing, how we are utilizing this facility or technology in our daily life. So as per the IP addressing system is concerned, this IPv4 was basically required to have this 2 raised to power 32 entities, because it was 32-bit. Then in 2011 in IPv6, it is 2 raised to power 128 entities. And so these are the basically unique addressing identities, which was based on IPv4 and then moved to IPv6. So from this particular report, which is Cisco annual report from 19 to 23, you can see that there are billions of machine to machine connections, and it was expected that by 2023, connected home largest and connected car fastest growth. So these two targets are basically we are going to achieve by this year, and it is going to be considered as the part of machine to machine connections or IoT growth. So if you see in this also in 2018 we have this connected home, which was 20% of this you can say revenue generation part. Then connected cities, 26%. Retail part is there, connected work is there, connected car, energy, connected health, manufacturing and supply chain, and others. And by the year 2020, so if you compare 2018 and 2023, you can see that this portion is majorly related to connected home, and then your connected work, then your energy system, and all that. But all these areas are basically going to you can say help in growth of IoT. And this growth of IoT will be implemented with the help of this new mobile cellular generation, that is 5G communication. So this is the transition we are expecting with due to IoT. And another expectation from IoT is that you can utilize your internet connection, or you can get connected with the internet anytime. And anytime means on the move, while you are in mobility, at night time, at daytime, when you are in outdoor environment, when you are in indoor environment, and that too away from your desktops and laptops, or you can utilize it on the systems. You can have this connection or connectivity or transfer of information or data between the computers from human to human, not using a computer. You can imagine if you are not using a desktop or another tablet or so, but you are able to transmit and receive the information human to thing using generic equipment, and finally thing to thing. So it means these three major parameters need to be satisfied to have this particular IoT connection. That you should have anytime communication, you can have any place communication, and you can have anything communication. So this was another prediction, which was by ITU, where they have presented in one presentation about introduction to IoT. That as we have said that in the year 2008 and 9, the number of devices connected were more on internet than on human beings, and that was also reported in that particular report, ITU report. They have told that in 2003 approximately 0.08 connected devices per person was available. Then 2008-9 approximately more connected devices than people, and in 2010 it was 1.84 device. By the year 2020 it was 6.58, or you can say approximately 7 devices connected per person. And you can imagine how 7 devices, as a common user, how many devices you are basically connected with at your home or at your workplace or anywhere else. So you can see that these type of devices are basically helpful to get this information. So this is the transition expected for IoT by the year 2025. That the major five predictions for IoT is: number one, that it will be global IoT connections will be 27 billion, which was 6 billion in 2015. There will be 27 billion connections for IoT. Then IoT will have a revenue forecast of $3 trillion. Then the major connections for IoT was because of the cellular IoT connections. Cellular IoT means a commercial cellular IoT network is going to be utilized for IoT applications, because for our connected homes or for our connected, you can say, dedicated or defined applications for a consumer, you can have Wi-Fi connections over there. But when you want to implement smart city projects, smart village type of projects, or different applications are under those smart city projects or smart village project, for example, for energy management, if I said smart grid, smart power generation, smart distributions, and your solar power distributions, and so obviously those are commercial applications, and your short range wireless communication technologies will not work for these type of application. And that is why that was the you can say the target of 5G use case also, because in 5G we have EMBB type of application. EMBB means your enhanced mobile broadband application, which are for a consumer. You can have your high speed internet access over your devices, you can have AR/VR facilities, or you can have ultra high definition screens, and so on. So those are the use case which have different types of requirement. Now second type of requirement is URLLC, which is ultra reliable low latency network. So this ultra reliable low latency network obviously means the applications which need reliable network and latency, very low latency. For example, your autonomous cars, autonomous vehicles, or self driving car, you can say, or robotic surgeries. Then your you can say drones facilities. So there are so many different applications which will cover under URLLC. And then third use case for 5G communication is MMTC. MMTC is massive machine type communication, because we are going to implement in IoT, and that IoT will be for different applications, different areas. Obviously those massive machine type communication is only possible when we'll have a cellular type of connection. So it is expected to have 2.2 billion type of connections with the cellular IoT, which was 334 million by the end of 2015. Now, again, another prediction is that 45% of cellular IoT connection will be in connected cars. And obviously, when you run so many applications over IoT, then your data traffic will be very large, and it will has high density, high volume network traffic will be there. So 2 zettabytes of data generated by IoT, and mostly from the consumer devices. Maximum of this data will be from the consumer devices. This is the prediction for by the year 2025 for IoT. And this transition and prediction is possible because we have new areas now which are appearing at the intersection between interconnected technologies and various industries. For example, previously we only talk about Internet of Things, but nowadays we talk about Internet of Medical Things, we talk about Industrial Internet of Things, we talk about Automotive Internet of Things, we talk about smart cities, smart buildings, smart agriculture, smart retail. So all these applications and much more applications will be implemented through IoT. Then obviously this five predictions will get obviously implemented, and you will get a transition from one phase of IoT to another phase. And another factor which are basically encouraging this rapid IoT expansion is falling sensor cost. Because if your applications are in demand, different applications are in demand, so obviously the sensors are in demand, and if sensors are in demand, so their cost will fall down. Then the falling cost of data collections and storage due to cloud solutions, widely expanding internet connectivity. Nowadays in rural areas also we have more internet connections also there. The internet, you can say, connectivity or you to the user by the service provider is very high, and then computing power of your devices is increasing, and finally the smartphone penetration. Each and every person nowadays has a smartphone, irrespective of the cost. The smartphone is available with each and everyone. So when we talk about this basic information about IoT, that IoT is going to change the scenario of our information transformation, and it will going to help in implementation of massive machine type communication. Then we need to discuss about the building blocks of IoT, the basic building blocks of IoT. I will not go into much technical content because there may be participants from different fields also. So I'm just going to give you a simpler presentation part related to this building blocks of IoT, so that you can are able to understand what IoT is going to how IoT is going to be implemented, with which type of elements are going to be utilized for the implementation of IoT. So the IoT hardware building blocks, you can say, is think. First block is think, second is data acquisition module, third is data processing module, and fourth is communications module. So, if you see any device in your home which is connected to IoT, you can easily understand these modules which are written here. Think, for example, your nowadays many companies has light bulbs, fans, each and everything available which can be connected through Wi-Fi. Even your AC, washing machine, fridge, everything. We assume we have a night lamp in our home, or lamp in our home, and that lamp is basically is your thing that you are going to connect. That particular bulb, light bulb, is you are going to connect, and you are going to control or monitor that light bulb, whether you will switch on that light bulb with the help of internet, you are going to switch off that light bulb with the help of app. Internet connectivity means your that particular light bulb will have some app, and you are going to install that app in your mobile phone, and finally you are basically controlling that particular light bulb with your mobile phone. You are switching on, you are switching switch off that particular bulb, you are changing the intensity, you are changing the color of that bulb, and so on. It means that particular light bulb is the thing you are going to control or monitor. Now, how you are going to control and monitor? You need to acquire physical signal, and now you have to convert that signal to the digital signal. So you are pressing that particular switch, and that acquisition module is getting that particular signal that you want that bulb to be switched on, you want that bulb to be switched off, you want that bulb to have a intensity level changes, you want that bulb to have a color changes, and that color changes with different intensity levels, and so on, whatever feature that particular thing have. So those data acquisition modules are basically capturing your signals. You are pressing some on and off button, and it is going to capture that particular information, convert that information to the digital format, and then giving that information to the processing module, because processing module now going to process that your information, and after processing you will receive some data, and after that you will perform some analytics and store the data locally and other edge computing devices. That can be possible for different applications, but for light bulb application we can say that we are switching off and on, that information is processed, and finally that information is given to that particular device, and you are getting that response on your mobile phone app. So you, if you are switching off, it is giving a you have a response that is your phone is that particular device is switched off, or that particular device is switched on, or whatever your instructions you have provided. So these are this particular part came into communication module, that you are basically communicating with the third party system either locally or in the cloud. So the app is basically communicating, and you are getting that response on your app. So ultimately, what information you are going to transfer to that particular bulb, it is going to be through your Wi-Fi connection, and that communication protocol is going to handle that your information will be transferred to that bulb, and a bulb will operate accordingly. So that is why these common features are the common hardware building blocks for any IoT applications. their internal, you can say, subcategories can be available as per the application, but the major front end portion we see is these four type of, you can say, elements or building blocks. And these are some of the IoT companies which are working rigorously for different applications, different apps, different solutions, consumer products, and so on related to IoT. So we can say the things and obviously equipments we are going to control or monitor. So IoT devices basically equipped with sensors and actuators, because sensors are going to sense the whatever sensor is there. If you want to check the humidity, then humidity sensor will be there. If you want to check the temperature sensor will be there, and so on. So a sensor will be there, then actuator is there. Actuator means which basically allow things to act. Whatever action you want from that particular thing, you are basically implementing that action through actuators. So you have to switch on or off the light, or you want to open or close the door, or whatever activity you want to have from that sensor. Then communication module, as I already said, that this module is basically capturing the signal and sending that signal to the concerned device, and then receiving the data and finally updating your on your app. So this is responsible for sending the data and receiving the data. In our normal home connected home devices, we have this type of Wi-Fi connections, and we implement all those applications through our Wi-Fi module. Then analysis and processing module, which is basically responsible for making sense of collected data. Sense of collected data means, suppose you want to collect the temperature of your room. So you are basically collecting the temperature at different intervals of your room or home or area, whatever you want to have. And then you need to identify what you want to do from that particular data. So you have to analyze that data, you have to process that data, and it means you are collecting the temperature information. Now from that temperature information, you want that if the temperature goes below that particular level, your AC should switch on. So accordingly you are making some decisions on the basis of analysis, and finally you are processing that module. It depends the capability of your sensor and module also. So in things, as I already said, we have different sensors. So we have temperature sensor, we have water level sensor, humidity sensors, air pollution sensors, and air quality sensors, and so on. So you have different types of sensors, and you can get the information by using those sensors. Then this total IoT devices, which have unique identities. So we can say that they can collect the data, these things basically, and they can exchange the data with other connected devices, and they can process the data either locally, or they can send it to the centralized servers or cloud-based servers, whatever information you want to transfer to whatever backend core network part. So that is why we have this particular sensor which is sensing the information. Now this sensor need to transfer that information to our uh, you can say acquisition module and processing module. So that part is connected through some controller which have some which has some memory. So those controllers can be your any type of controller. You can use Arduino, you can use Raspberry Pi, you can use Arduino Uno. So you have different variations, different modifications of those controllers, and you can utilize those controllers to capture the data from the sensor. And there is a protocol between the sensor device and the controller, which is going to handle the transmission and reception of that particular data from one part to another part. And finally you are going to transmit that part to the wireless next device, and for that you need wireless link, and obviously for wireless link, wireless protocol is going to be utilized. So as shown in this, that we have utilized Wi-Fi connection. So there will be a gateway, and the actual work of gateway is to provide connectivity between the things and the cloud, because from gateway you are basically transferring the data from thing and you are transferring that data to the cloud, and similarly you are getting some information from the thing and you are transferring that information to the from the cloud and transferring that information to the thing. And these links can be any of the module you are going to utilize for your application implementation. So we can say that gateway is considered as a gatekeeper because it has information of the data which is going away, going out from its the gateway, and the data which is coming in the gate from the gateway. So you can say that it provides connectivity between things and cloud. It basically translates different network protocols and makes sure interoperability of connected devices and sensors. Then it also enables data processing and filtering before moving it to the cloud, because you are not going to randomly send everything to the cloud. It is a storage, so you need to just identify which type portion of the data you are going to send. You are going to compress that data so that the volume of the data is will be reduced, and finally you are transferring that data to the cloud. And it also transmit control commands going from the cloud to the things, which then executes command using their actuators. So this is the part of IoT in which we are going to connect things with the clouds, which is called gateway. Now, next is communication module. The next thing which came into picture, which we need to just have a brief information, is communication module, because that particular module is responsible for sending and receiving the data, and you will have connectivity between things and cloud. So you need to have that wireless link protocol, and those protocols will depend upon which type of module you are going to utilize. So different low power wireless networks are available. For example, Wi-Fi, Zigbee, Bluetooth, Z-Wave, LoRaWAN, etc. And these standards, some of the standards are basically called as short range standards. Some are called as long range standards. And which type of protocol you are going to utilize, it depends upon the application you are going to implement, and also whether you want a solution for your indoor application or you want a solution for your outdoor application. It also depends upon this particular part. And in all these communication modules, whichever communication modules available for implementation of this IoT, the main consideration and the trade-offs which is considered while deciding the communication module is the power consumption of that particular module, the range which is going to cover. As I said, it is a short range or a long range, so your application is indoor or outdoor, depends upon that. And finally the bandwidth, because you are going to utilize that frequency bandwidth for transferring the data, so your data rate will also came into picture when you talk about the applications and the use of communication module for a particular application. So we can say any of the module can be utilized depending on the applications we want to build with this IoT. Now when we talk about this cloud is just, we can say that it is a unit which basically collect, process and huge amount of data. And when data from the cloud can be accessed remotely, and accordingly critical decisions can be made when necessary. So IoT cloud is a high performance network of optimized servers, you can say, which perform high speed data processing of devices, traffic management, and also deliver predictive analytics. So this part, now nowadays nothing is you can say it is related to electronics or it is related to computer or mechanical or so on. There are some big short terms you are basically hearing every day. One is obviously IoT, second is 5G, third is your big data analytics, then machine learning, then AI, deep learning. So you can say all these units. Previously, we basically said that this software part is related to only computer science department, hardware part and electronics module is related to electronics department or electronic field or so. But nowadays each and everything is interdisciplinary. Electronic people are utilizing data analytics, electronic people are utilizing ML, AI, and deep learning. Similarly, computer science people are utilizing this hardware part of IoT, or they are learning about 5G communication. Mechanical person, electrical person, they all are basically looking for these type of you can say contents, because they have applications. All these contents have applications in one and another areas, so they can be utilized. Similarly, if any of the person which is going to have an connections of devices or implementation of IoT in some application, so the next part which came into picture is that you have collected the data, you have processed that data to the cloud. Now you have decided that you have some information. What you are going to do with that information, that is basically called analytics, that you are going to analyze and decide what you are going to do with that particular data, because data is a very important thing related to any sensor, related to anything. So it could be very simple, by checking a temperature reading within acceptable range. One type of application would have just only this type of information, that you are just collecting the temperature reading from that should be in acceptable range. This type of application can be implemented at your home. You are checking the temperature of a room, you are checking the temperature of your any device or so on. This type of temperature reading can also be implemented in any industries or IoT, in any factory, industry, or anything, anywhere, because you need to just have this reading, and on the basis of those reading you are going to analyze what you want to have the effect of or outcome of that particular analysis. So first thing is that it can be a simple analysis, it can be a complex analysis. For example, if any of you who is working in image processing or computer vision and so obviously you want to identify some objects, you want to identify something. Nowadays people are working towards security in you can say smart city project. Under smart city project, they are working for security level, and they are also working for transportation management, for example for traffic management, for this type of parking management, your congestion management during the traffic hours, busy hours, and so on. And also in security and defense, for example, intruders, identifications of intruders, and so on. So, under this smart city project, for example, in Chandigarh itself, we have cameras which are connected to the centralized server, and all the challans nowadays are basically digital. So, you just get, if you have violated some traffic rule, you will just receive the challan on your mobile phone on because your HSRP number plate is there. That particular camera is going to capture the image. It is taking the image of your number plate, it is getting that information from this HSRP, and every information of the owner of that particular vehicle is going to be there. And the challan will get you at your home or on your devices, email ID or phone number, whatever information is available with them. So this type of part is little bit complex, because you need to identify some information, and in that particular application we are basically getting the information of our number plate, and from that number plate we are retrieving the information of the owner of the vehicle. So now whenever this particular application is going to be implemented, we are basically analyzing that data, and we are deciding that we need to send the challan, whether this person should be challan for the violation or this person should not be challan for the violation as per the rules. So these are the analytics, and accordingly reporting will be there. Similarly, enterprises which are using massive data collected from IoT devices, they are going to utilize the insights for their future business opportunities. As we search anything on Google, we search anything on our e-commerce sites, whether Ajio, Myntra, Amazon, or anything, or even your entertainment sites, your Amazon Prime, Hotstar, everything. So you can you observe that whichever thing you have searched, or whatever information you have searched on those sites, Similar type of solutions or similar type of informations are now going to be available in the side window of your information on YouTube also. If you search one type of video, then similar type of videos came into picture, and you are going to see these type of videos back and again and again. So it is because they are analyzing that data, they are looking for the opportunities that this particular person which is utilizing this information, searching for this information, is a need of having this type of, or is in a basically habit of having this type of purchasing or so. So they are going to give you the information so that you will have their future, you can say, customer. So they are going to have a future business opportunities, they are going to see future business opportunities in a users, in different users. Then improvement of products, obviously improvement of services, preventive measures for their certain steps, and so on. So you can imagine that this analytics part is very important part related to IoT data, because different commercial businesses are also decided on the basis of this. So we can say from this diagram, we can say that we have, you can say, some IoT devices, different IoT devices. You are transferring that information to the gateway. Gateway is connected to basically internet. From internet, you are giving that information to the remote control process, your analytics, and finally, you are also having some data storage solutions. So these are both ways that you are getting, retrieving some information or you are transferring some information. On the basis of that, you are basically deciding this particular part and the route. For example, you can say this blue part which is over here, we can see that it is a collection of device will connect to the internet. Then this orange part shows that a gateway will allow device to connect via the Wi-Fi. Then this green part is showing that the internet will provide connectivity for the IoT. And then if you see this red, so the data storage devices will collect information for further use. And this yellow shows that remote devices, like smartphones or anything else with the control of IoT, is connected with the internet. So this is the Internet of Thing basics, that how it works basically. Now, if, as we have talked about the first slide, ITU has reported a definition and obviously a full report on IoT. So they have also identified one IoT reference model. So this reference model, if you see, we have different layers. One is device layer, then network layer, then service support and application layer, then application layer. Then these devices should have some management and security capabilities. So each and every layer has some generic support capabilities and some specific support capabilities related to this management, security, and service support and application layer. So if you see, suppose you are just controlling your smartwatch with your mobile app, and you are just getting that information. So it means your smartwatch has the capability, or that particular device has the capability that you can have access to this any particular information. You are getting the information of your heartbeat, you are getting the information of your sleep rate, you are getting the information how much time you are in deep sleep, how much time, for how much time you are in a awake mode, or for how much time you are in a you are not in sound sleep, and so on. So it means that particular device has capabilities. So you and those device capabilities obviously differs from one device to another device. If anybody has Apple Watch, they had different capabilities. If other companies watch, they have different capabilities. So it means device capabilities are different. And similarly, the gateway capabilities are different. Which type of gateway we are utilizing, accordingly the capabilities will change. Then major concern came into picture is related to this generic security and specific security capabilities. If you people are using mobile banking or e-banking or net banking, so obviously their security algorithms requirements are going to be very strong and trusted, because they are for a consumer which are going to transfer and receive money and doing providing their bank details or informations on the internet. So obviously they have some specific security capabilities which will not be available with other applications. And other applications, I can say, if a camera is installed in your office or at your home or any other place, So that camera application will not have specific security capabilities which is provided for net banking. So it means any applications which you are going to utilize is particularly have some standard features, and if you are going to imply that particular application for some specific you can say defined applications, so their security levels, their management levels will be different, and that is defined in IoT reference model. Because why we need these type of reference model, basically, as I've said, an example of cameras. You normally we all install cameras in our homes for the care. You can say the observation or taking care for our elder parents, taking care for our small children, which we basically left back home with our house helps and so. And even nowadays, even kindergartens or playways, all these type of support systems, they also have these cameras installed in their premises, and they give accessibility to the user or consumer of their basically the parents of the student. They are basically admitting in their uh, institution. So that is why if they are not handling those devices properly, if they are not managing those devices properly, so some other person who knows the loopholes or security holes, you can say leakages, which is possible to hack the device, will able to hack the device, and obviously we can get that information or anything related to you can say which can harm that particular institution or those students or whatsoever. So they can easily do those type of things. So we need to identify the security capabilities, we need to identify the capabilities of the devices as per the applications, we need to standardize those capabilities as per the applications. So that is why some IoT forums, they have identified some major concerns related to securities, and they have decided that all the consumer internet connected devices password must be unique, because nowadays the maximum utilization is from the consumer devices, and those consumer devices are installed at our homes, at our offices. So somewhere in the premises where our privacy is also at, you can say, risk. So that is why they have identified that it should not be you can say resettable to any universal factory setting, and then they should have passwords and which should be unique. Second, the manufacturer of consumer IoT devices, they should have a public point of contact, and that is why nowadays each and every company which are basically providing consumer electronic products related to IoT, they have their customer care centers also, and so that anyone can report a vulnerability and it will be acted on in a timely manner. Third part in that is important point is manufacturer of consumer IoT devices, they should explicitly state the minimum length of time that your device will receive the security updates. It means your devices should updated, security updates should be very regular, and they should have either in store or in online mode. So any question till now from any of the participant? So another topic which is concerned to IoT, in which energy management also came into picture, is related to smart homes. Because each and everything we are now going to connect our devices on Wi-Fi or internet. So obviously, the major concern related to that part is that your devices capabilities should be secured, and you should have the full implementations of those applications which they are dedicated for. And in that, some surveys are also done, some research has been done, and people are doing lots of research, and they have identified some use cases or you can say applications for IoT related to smart homes, which are not related to consumer products which are we are using, but related to smart home. Because one part is that adaptation and personalization consider the ability of smart home to automatically tailor its services to the individual user needs. Smart home, basically, we are considering that our services or our requirements will should be satisfied by the utilization of the machines or by the utilization of the different types of applications provided by the IoT. So that is why often achieved by building on generic services designed for specific group of users also. It means your applications should also be generic, your applications can also be specific, and in that specific application for smart home they have identified children or elderly, and then by adapting the behavior of the service to the habit of the user. It means they are basically observing, you have installed cameras, you have installed some devices on over there, and you are observing your children or elderly people, and then you are basically how what you are observing the behavior of the services to the habit of the user. It means suppose you have installed some cameras or you have installed some sensors on your elder parents which are not able to move very freely, and they have a fixed routine. They are basically working, they are having a exercise routine from this time to this time, they are having a breakfast routine, they are having some nap routine, then again they are having some exercise routine, and so on. So it means they have a fixed habits, they have a fixed behavior in your daily life, and if they found some deviation from these habits, if they basically want to identify those, detect those habits, they want to discover the deviations from those habits, so that they can build up some business logic from these services to be provided for the application. And if you remember, if you have seen some of the applications uh, related to these type of concerns or these type of part is the part of Shark Tank India. There are many episodes in Shark Tank India season 2 also, in which they have identified the utilization of IoT in different applications, whether you are utilizing for a consumer product or utilizing for a specific users. And in that IoT is coming into picture, because you are basically reporting that part to wirelessly. So that is why if they are able to detect those habits, if they are able to find out or discover the deviation from these habits, so they can also find out a solution for the problems that suppose there is some patient, and those patients require some urgent medical information. So it means they need to identify what is the requirement of that particular user, and they can provide the solution accordingly, whether they need a ambulance or they only need some other help. So they can identify. So this ultimately going to help them to have a business logic from the service or the application. And but for implementation of these type of services, they need a strong convergence among the sensors, and they also need activity recognition procedure. So this is one of the area where anybody who want to work for the specific application of smart home for elderly healthcare or children care, they can identify. Similarly, another important which is topic in developed countries related to that is detecting fall for elderly people living independent. Because in some of the areas in France also, for instance, it is one of the most frequent cause of emergency calls and of medical intervention for elderly at the home. And if we have the observation these type of applications implemented with the help of IoT, so we are easy to identify the problem, we are easy to find the solutions to analyze it. Because suppose there is some fall of elderly citizen at the home and nobody is at the home, you are just going to identify whether that particular person is having some serious injuries, or that person is having some just a fall and he is going to be okay within few hours. So that is why accordingly your medical health requirements, your ambulance requirements, your any other facility requirements will be identified, and they can be sent to the particular victim at the time, say you can say within a time. And that is why this particular part is also another topic related to IoT application for smart homes. And this is also going to help in the smart environment also, because with this decisions you are going to save so many resources related to those particular problems, and you are going to have the safe environment and smart environment facilities also for health related applications. And for any type of applications, whether general or specific, as I said, we need some different scenarios. One is indoor smart environment, another is outdoor or long range smart environment. For indoor, the majorly concerned part which we people large use very rigorously is Wi-Fi. Each and every person has Wi-Fi modem at their home nowadays. They have a single frequency modem, two frequency modem, even optical cables are now light down by service providers. So you have fiber optic cables to your modems and so on. So accordingly, the major concern is that whatever facility you are going to utilize, you need to identify the ranges of those facilities, and you are need to identify which type of data rate you want from your scenario, that particular solution, communication solution. And so in long indoor environment, we have Bluetooth, Zigbee, Wi-Fi. And for outdoor environment, we have cellular systems. Cellular system means your 2G, 3G, 4G solutions, which are going to be implemented for IoT also. Then we have IEEE 802.11 AF. Then we have weightless system also for machine-to-machine communications. So these are some newly identified, you can say, ranges or solutions provided, and some previous already established standards are also there. And one more solution which was provided in release 13 by you can say 3GPP, third generation partnership project, which is a body responsible for the identification of solutions for different cellular applications. And in that they have identified narrowband IoT. This narrowband IoT is basically 4G band structure utilizing for LTE frequencies, and it is going solution to the cellular applications of IoT. That is why it is cellular part of a cellular IoT. And they are going to have devices, narrowband IoT devices, which can be sensors, actuators, wearables, cameras, anything which are going to be connected devices or things on large number. And these solutions are basically provided in licensed spectrum bands, because up to this we have these bands. These are unlicensed spectrum bands. Anybody can use these bands, and each and every consumer electronics is on unlicensed band. But for these type of applications, for some of the applications where we need narrowband IoT, cellular IoT as a solution, then obviously we need to utilize low licensed spectrum bands. For example, they have identified narrowband IoT applications for different, you can say, applications related to smart city project or smart village project. So you can see these are basically considered the part of the management, and in some of the applications are directly or indirectly related to your energy or environment, basically energy management or environment. Because whatever the major concern related to IoT solutions is that we are basically saving our resources. We are utilizing one part of resources, but we are saving the other part of the resource. And we are implementing those solutions on or we can say we are providing in time solutions for a problem. We are providing early solutions for a problem. So it depends upon your problem which type of solution is required. But ultimately we are you can say keeping our responses or uh, devices towards the energy management part. So as you can see, if we are going to implement water meters, so particularly one base station will cover some area. So under that area, how many water meters are required, how many gas meters are required, waste management bins are required, pollution monitoring sensors, pollution altering sensors, public lighting, parking management system, watering system, self-service bike renting system. Each and every solution is the part of smart village and smart city project. And if you have identified the number of devices you are going to install, then second part is you need to identify the reporting time of the particular part, that how much time your device will going to report to the base stations. Then the data bits they are going to utilize, then the how much time you need to have the information from the base station towards the device. That will depend upon the type of device. For example, water meter, you can see you are reporting once per a day, and you are getting information from the core network once per week. But for gas meter, you are reporting 4 times an hour, and you are getting information once per week. So like this, you have different systems, applications, and on the basis of those applications, you are basically identifying the reporting interval in both uplink and downlink, and on the and also the data bits in both uplink and downlink. So this will save your you can say manpower. This will save the your energy, and you will have a solutions, uh, efficient solutions for a problems, different problems. And also on the basis of that, you are going to identify the reports, how, which type of reports you are going to generate. Whether smart home, it will have a periodic reports, because every device is working as per the schedule, and you will have a periodic reports. But for gas station sensor, there is some information to be transferred to the core network, then core network is sending some command, and then command, on the basis of command, you are getting some response, and so on. So it is a command and response type of traffic exchange. And third type of report is exceptional report. Exceptional report means the applications which are going to produce reports exceptionally or whenever necessary. So smoke alarm will give report only when there will be some utilization of that alarm, and it will provide a report. So these are the topics related to IoT, and narrowband IoT also, Wi-Fi also. So as per your application, you are going to identify the protocol communication module. You are going to identify the number of devices you are connecting. Going to identify the reporting time and the reporting type. Next is the connections. That how these different types of connections are we are utilizing, and we are basically going to utilize in this year. That 3G was there in 2018, but it is now declining. Then 4G came into picture, and 4G is now increasing. Then 5G is now moving up, and LPV, low power wireless access, whether it is cellular or non-cellular, they are basically moving upwards, and they are going to be utilized for billions of devices or connections. Similarly, by the year 2050, we are in this scenario in the year of this, and we are expecting connected cars, then in full implementation of Internet of Things, and by the 2050, the utilization of different applications. So you can see that whether in that particular area, this particular range is the range where one computer and many people. Then a range came where one person, one computer, and finally this particular range, or you can say, came into picture where digital native computing, one person with many screens, and finally Internet of everything. We are expecting to have Internet of everything, implementations of cognitive computing, implementation of artificial intelligence in different things, and so on. So this diagram basically shows that what is the effect of, you can say, digital revolution in coming years, and how we are going from one computer, many people, to we have moving towards Internet of everything. And this is another applications, general descriptions of IoT for smart environments for health. For example, we have a patient, we have some wearable or integrated environment sensors related to that. So and some family or care workers or medical staff, anyone will have the access to the information, whichever access you want to give, and then that information is going to be immediate biofeedback loop to the user, and remote monitoring loop is also there. So you can see that use of IoT for different applications will ultimately help for having a smart environment, and this is basically for the health sector only. So in this, we all have utilized this particular app at least once in the year 2020. So that is Arogya Setu app. And the app was basically as a coronavirus tracker of sort, which works on the basis of contact tracing. And it is the objective of this app is to help a user identify possible coronavirus hotspot around his or her area. And it also helps people to identify the symptoms, alerts, and so on. So this technology is basically working on Bluetooth low energy, and they are basically getting the information on the basis of this technology, transferring that information to the particular user in the app. You are all are aware with this app, Arogya Setu app. Then second is environmental monitoring, because ultimately your energy part, which is related, that how you are going to save the energy, how you are going to utilize efficiently the energy, and this particular energy management will help in environmental monitoring also. So this IoT becomes ubiquitous, and the type of applications are more imaginative nowadays, and it becomes necessary to be more imaginative because we are going to have implementation of autonomous devices. So that is why the term environmental monitoring is very much dependent on one's definition of the term environment and the individual constraint that each brings, such as available forms of energy, containment issues, and accessibility. So these are some terms which are related to energy environment monitoring, and energy is one of the factor of constraint of that particular part. So in environment, you can say you have uncontrolled environments and you have controlled environments. So in each different environment, different forms of energy harvesting can be used to process the available ambient energy into a usable source of power for sensors. It means whether when we talk about this environmental monitoring or when we talk about energy management, we need to deal with different parameters which are under control, which can be controlled, and the parameters which cannot be controlled. For example, if you have the area where you have uh, dense forest, so that is an environment where we have dense forest, and if you want to implement some sensor network over there, some sensors we want to deploy, some sensors, so obviously those sensors will consume more energy because we need to transmit the signal, we need to receive the signal. So those parameters are not going to be controlled because that environment is uncontrolled environment, we cannot control that environment. But there are some applications where we can have we have you can say ample amount of sun rays, so you can utilize solar powers over there and solar power sensors over there, and you can utilize that particular energy. You can utilize that energy for harvesting also, you can utilize that energy for different applications also. So this part is your controlled environment because you know that you have sun rays, you can utilize the sun rays for some charging power, solar chargers, solar powers also, and you can utilize for harvesting also, you can utilize for distribution also. Similarly, the energy distribution part, the smart grid part, which came into nowadays people are working on. So under those smart grid parts, we need to utilize those applications accordingly. And for example, if we talk about integrated smart energy system, we can see that how IoT is utilizing. We have some regulations and markets, we have demand side services, we have utilities and generation. So you can see that ev chargers, ev vehicles are now available, ev vehicles are available. So obviously we have smart mobilities nowadays, ev charging stations are over there, and those charging stations you are utilizing and to should be efficiently utilized, so obviously management will be there. Then we have energy democratization, that you are going to utilize uh, commercially, how you are going to utilize those for uh, uh, you can say commercial energy management, you can say. Then your digitized energy generation process should be there, so losses will be less. Then fault maintenance and preventive maintenance will be one of the part of the smart energy system. Optimized energy grids, then distributed energy systems related to that energy part, and demand and response, smart buildings, energy efficiency. In this one big session, I think you have some lectures related to energy efficient buildings, or related to that part, civil part, or some other areas also. So it means we can say in each and every area, this smart energy system is a requirement, and you need that particular requirement over there. Similarly, some part of IoT is going to be utilized in agriculture, where we're expecting that $15.3 billion market will be there for agriculture. Then we have different applications, use cases in agriculture also: monitoring of your climate conditions, your greenhouse automations, your crop management, your cattle monitoring, end-to-end farm management systems, etc. All these are available with the this particular part. So in climate conditions, which is considered a part of precision farming, you are basically having sensors which are measuring information related to environment, relation to uh, climate conditions, providing that information to the server, and you are choosing solutions for that, that this particular weather or climate condition is suitable for this particular crop, and so on. So you are improving the capacity, and that is why it is considered a part of precision farming. Similarly, greenhouse automation, greenhouse automations, you have so many applications, few of them are mentioned here, and those applications can be controlled with the help of IoT, because one part is you are implementing some smart meters, water meter, or gas meters or so on. But other part is, you if you want to automate that system, it will obviously increase the efficiency of the system, and it will save the energy also. So this data ultimately, which we have automated, so we can be converted to desired format for easy understanding also. For example, all this data is controlled by the controller through IoT gateway. It is provided for remote monitoring either on your mobile phones or on your screens. Then crop management, crop sensors, which are going to be utilized for crop farming, such as temperature and other informations, which will help in monitor the crop growth, and also to find out the anomalies in the field, so that we prevent any diseases which can harm the yield. Then cattle monitoring. These type of cattle monitoring solutions, this RFID tags, they are easily available, so that we can identify and their temperature, health, activity, and nutrition inside, and we can have a collective information. We, as a herd, we can have individual information also. And for large scale cattle farms, it is a very productive solution, and it will obviously improve their productivity also. And end-to-end farm management, large farms, they can have IoT products in agriculture, and which ultimately help in saving premises also, and powerful dashboards capabilities also for reporting features. Then waste management is another solution for IoT, and smart waste management again, that you have optimized routes, you can identify optimized routes, and you can identify the solutions for those optimized routes. Vehicle tracking, because we need to use road sensors and intelligent display systems, because using these systems will help the driver to find the best path for parking in the city. So it means it can consider under parking management system also, because the benefit is faster the car takes to locate a parking slot, means lesser CO emission from the car and lesser traffic problems, obviously. And also you have a better environment because of this lesser CO emission. So as you can see in this diagram, we have a vehicle unit, we have a cell tower, we have GPS satellites, and they are connected together, getting the information and giving that information to the user, so that user can easily identify the parking slot, and it can easily integrate it with the vehicle parking facility. So the utilization of this IoT infrastructure is going to help in one way or other way to have the management. Then warning systems. One of the warning system can be changes in water quality level of a particular reservoir or so on. And people are working for this also. Some connections of different sensors and monitoring systems, which can have the information of water levels, which can provide the flood warnings and other disasters also, such as earthquake. And one of the real-time example of earthquake system is which is installed in Delhi Metro. And this early earthquake warning system was implemented by CSIO Chandigarh, and it is they are utilizing this earthquake system in Delhi Metro. And they are also have some modification over this system. Now they have implemented fog computing, edge computing over their systems, so that they can early information of the earthquake, and they can stop the metro whenever it is necessary. Similarly, the potential landslides in some areas, assisting the civils and authorities to take drastic action on such issues, and so on. So it means this can also be implemented for that warning system solutions also. Then deforestation processes, sensors which are attached to trees, monitors detect illegal logging and poaching at a great distance. Some has certain sounds, but we are basically going to identify. We have certain sounds with illegal logging, which are chainsaw, large vehicle in authorized area, and we can stop illegal activities in those areas also. Similarly, for cameras can be utilized, motion sensing cameras for wildlife preservations, to monitor them, to preserve those species, and also to identify rare species and illegal hunting and poaching over there. So you can see different types of solutions for IoT in different applications. And for energy system, the direct application which is implemented is use of end-to-end energy monitoring solutions from Prayas Energy Group. And this energy group successfully addressed the severe energy shortage in small towns and villages. They have IoT connected energy meters, and they have connected 100 villages with efficient energy in the first phase itself. Then M Krishi app, which is again related to service delivery platforms for the low crop yield in unpredictable market conditions faced by the farmers. So they are basically addressing this particular issue, and they have provide solutions for five digital forces for social networks, mobility analytics, IoT, and cloud. And they are providing market and climate tech entities. And by the 2020, they aim to push 100 millions of users to be crossed on their app. This is a Tata app, and they are utilizing this app basically with the help of TCS. Then these are different platforms available in whole. If we see that we have some hardware, we have some IoT middleware platforms, and we have different applications which we are implementing through our combinations of hardware and softwares. And similarly, if anybody who want to do IoT based project for village, whether related to energy sector, related to environment sector, because if you are working for environment, more or less you are working for energy sector. So you can have centralized system interfaced with with many sensors for making the village cleaner and smarter. And under that, you can implement these type of aspects also. There are some few more aspects, but few of them are digital display of government subsidies and offers to the farmers, smart garbage management system, e-learning for students, intensity-based street light monitoring system, and digital water supply. Because these intensity-based is one of the major part related to energy system, because you need to identify, instead of utilize, switching on the light all the time, whether it is a daytime or a night time, you just identify the intensity. You use the sensor and you identify the intensity, and on the basis of that the street light will switch on. Otherwise it will get move into the low intensity mode, and so on. So there are so many different variations related to these intensity based street light monitoring system. So there is one more study available from Department of Telecommunication technical report related to IoT and ICT enablement in the smart village and agriculture, and also related to other sectors. So they have identified some smart villages. One is Muri village in Andhra Pradesh, where they have provided every household with 15 Mbps of internet connections and cable TV telephone connections through fiber grid also. And they have provided e-banking, AP, RuPay cards, SBI Buddy, etc. facilities they have utilized. Then Pansari village in Gujarat, where they have used the solar power for agriculture purposes, and accidental insurance cover to one member of every household, air-conditioned primary schools with no dropouts, bus facility for all households, and focus on behavioral changes through campaigns and awareness drives. And similarly, in Uttar Pradesh, Takodarpur, and which is country first smart cow, and they have the two friends from that particular village created an app, Smart Cow, and which connects the entire population. And they have also provided the proper waste management system over there. And also served as a knowledge and information center through this Smart Cow app, and they have provided the marketplace, helpline, and a development tool. So this is all about IoT